Hello everyone, my name is Guido. I'm a software engineer here at xgeeks, and today the talk that we are going to have is about learning LangChain, so LangChain one-on-one. And this, for this purpose, and for us to understand LangChain, I've brought here 4 use cases to help you to understand the features that LangChain provides and how can we use them on our own applications. But before we start, let's try to understand what is LangChain. And LangChain is an open source framework that was launched on October of 2022. It was one of the fastest growing frameworks or open source projects on GitHub, and at the moment it has around 62,000 stars. So a lot of people like it, and that's why we are talking about it today. And for those who are not familiar with LangChain, and you look at it for the first time, you might see it as a wrapper on top of an API. But LangChain is much more than that, and that's what we are going to discover. LangChain is a simple and powerful framework that help us developers use large language models to power our own applications. And one of the things that it does and that it has, it supports out-of-the-box use cases like question and answering, like document analysis, summarization, and those are some of the topics that we are going to talk today. And how does LangChain does it? How does LangChain does all of this that I've spoken here a little bit? LangChain was built with a modular approach, and they try to make their components as modular as possible, and they allow us, the developer, to pick and choose which modules we want to use. And because of that, it allows us to make these chained, hence the name, these chain calls and integrate different components and different tools in order for us to use and to build unique applications. Well, this is all theoretical stuff, and I'm not really good with theoretical stuff. I like more of the hands-on approach. So let's go ahead and jump into the first use case, which is how do we query an LLM or a large language model using LangChain. And in order for us to query a large language model, the first thing that we need is a prompt. And a prompt is nothing more than a simple string. There are different ways to build it, to build different types of prompts, but the most simple one is just text. And with this text, and after we have this text chosen, we do need a model in order for us to, well, query it, right? So in our case, we are going to use OpenAI and GPT 3.5 Turbo for those interested in the model that we used here. And what we do here is we prompt the model for a result, much like you do on the browser when you are using ChatGPT, right? And if our question is which dish is popular in Portugal, the model says that bacalhau à Brás is a popular dish, and it also tells us some of the ingredients on how to make it, right? And however, simple prompts and simple text is not enough, so LangChain came up with this prompt templates, which allows us to specify variables inside our strings. And for us to do this, we have these prompt templates. By using a word surrounded with curly braces, we can replace all that in the text for whatever we want, really. In this case, I'm changing the location for a location that the user might specify. And everything else is going to stay the same. So the user is going to just specify a location, everything else stays the same, and we have a variable template that allows us, if we follow the same principles from the last example, to specify a location called Spain, or Spain in this case, and get the popular dish for Spain. And in this case, a popular dish in Spain happens to be paella. Does anyone here has tried paella before?
Yes.
Yeah? And do you know how to make it? Yes? No? Well, I think the model knows how can we make paella. And we can create a new template and we can write everything our own. But we are developers, we are lazy, we want the computer to do all the stuff for us. So why don't we chain it? So we chain our first prompt template, we wrap it on an LLM chain, and we chain it with a second template. And what we are trying to do here is for the output of the first chain to be the input for the second chain. So as you saw in the last example, the first prompt template will output paella as the dish that's popular in a specific location. And here we have the dish as the input for the second chain. And by creating these LLM chains, we can specify a location and get the result for the last link of the chain. In this case, we run it through a simple sequential chain because one after the other. So the first one is the location, the second one is for us to get the recipe. And then when we run the chain, we run it with just the first variable, which is Spain. And instead of getting paella, we get a list of ingredients and instructions on how to make paella. And up until this point, we were just working with text. So the output of the model was text. But if you are using this on your own applications, you might need the output to be in a different format, because you might want to send one thing to the user and then, well, you know how that works. And instead of us having to parse this text ourselves, we can output that logic into the model and ask the model for it to format its own output, of course. And in order for us to change the output into what we want, we can have a structured output parser that's based on a schema. First thing that we need to do is define the schema that we want the model to make the output like. In my case, I want to have a name, the name of the dish. Then I want to have a list of ingredients. And keep in mind that the description here might sound like something really simple, but it tells the model how that object is going to be constructed. For instance, the name of the dish, as the description, is going to be a string because it's just a name. But the other one, a list of ingredients, it tells the model that I do not want a string, I want a list, an array of ingredients. Well, we feed our response schema through a structured output parser, and we then have to get the instructions, because LangChain behind the scenes will create the instructions that are sent to the model in order for it to format the response in a specific way. And then it's just a matter of changing the last chain that we created, the last step of the chain. We have to specify a format instructions as a partial variable. And we have also, because we are having it here, then we have to pass it here as curly braces, because that's how we can define variables in LangChain templates. And here is where I've swapped the last chain link, and we run it again for Spain, and the result, instead of being a text, is going to be a JSON object with the dish and a list of ingredients, or an array of ingredients. And this is very powerful. You can do a lot of cool things with JSON parsers. There are other types of parsers, but JSON is the most used one because, well, if you send anything to the front end, or you might use JSON. Now, on this use case, we learned a little bit about the prompts. How can we change how we can change the output with a output parser, how we can work with prompt templates, how we can create chains, and specifically a sequential chain, and how to query the model. But that's a small drop on what we want to do, because most other than not, we want to chat with the model. And I've mentioned this before, unless we actually been living under a rock, Everyone, I probably think that everyone here uses ChatGPT at one point or another. And ChatGPT happens to be a conversational model that works a little bit different from what I showed before. Because it is a chat model, we need to provide it with different things that I showed before. But the basic of it is that they receive messages instead of strings, and the messages here can also be a prompt template. But there are different types of messages. Each one has their own purpose. We have the system message, which gives the model a helpful background that tells out the AI how to behave, how to work, and how it should do the things. So in my case here, I want the AI bot to speak as a pirate, and I want it to speak it with short sentences because I don't really like to read that much. Then we have human messages. Those are the messages from the users that are using the application. And we also do have AI messages, and those messages are the ones that the AI will respond. So this is helpful for the model to know who said what, and in order for us to actually chat with the model, instead of having our model being an OpenAI model, it's a chat OpenAI model. And this distinction is important because of the endpoint that we are making a request to. The principle is the same, but instead of passing a string, we pass an array of messages or a chat message history to the model. And by sending this, we get that we should set sail for the Caribbean to see beautiful beaches. Well, this is fun, but APIs are stateless most of the times. And because APIs are stateless, we as the developer are the ones that should keep track of the state for every user. And we can do this manually. We can append what the model said and push it to our array of messages and so on. But this will work, but this can be super cumbersome. And like I said, we are developers, we are lazy, and we like things that are more, that don't require us to do that much. So LangChain, again, got discovered, and they have this module, this chat message history module that will help us to create a history of the conversation. And instead of us having to create a new message with a specific, so a human messages or an AI message, they have these abstracted methods that allows us to add the message just by sending the string to it. And it will keep an history of the conversation. And in this example, the chat message history that I have here, it's a memory history. So everything that's going on will stay in memory. But LangChain has other types of histories. They have databases. You can store your chat history in a database. You have file-based history where you can save your history into a file and keep it in disk, or you can have it in cache, like by using Redis or some other caching mechanism. And the only difference there is, instead of us having to use the chat message history, we have another class for that specific implementation. And the methods that it extends are basically the same. And because I've added those two messages into the history, we still get the conversation going. And with this, our chat has memory from now on, and we can keep adding messages as they come and go, but yeah. In this use case, we learned about chat models and how to keep history between models. And now we are going to take a look at a more unique a more, sorry, a more unique use case, which is summarization. And I brought this here because this was one of the first real life and in-work problems that I faced. That was, by doing summarization, we faced some unique challenges. And I bet that anyone that's going to be using a large language model or a generative AI is going to face the same issues. So I think this is a very good example here, which is how can we summarize text? And text summarization is done, and the first thing that I need to do in order for me to summarize a text, I can write it myself, the editor, and have that. But more often than not, I want it to be I want the text to come from a document. And in my example, I have a mini story, which is a text file. And it comes from, actually, the ChatGPT wrote that story for me. And I saved it to a file. And I want to use it, and I want to have a summary of that story. And the first thing that I have to do here is load it from the file. And I could have done it myself, but then again, I do have LangChain, so I might as well use it. And they have all types of loaders. In this case, I have a text loader, but they do support other loaders like CSV loaders for Excel files or for comma-separated value files. They have PDF loaders, HTML loaders. They do even have loaders for Notion, for Confluence. They have all these loaders that allow you to get information from external sources. And when we load the document like we have here, instead of just getting the information that's on the model on the file, we do get a document that contains a page content, which actually is the content of the file, but it also provides metadata from where it got the information from. And this can be used to do a lot of things, at least when you are loading from different sources, you can refer to the metadata to know from where that information came from. And now that we have loaded the history, we can use what we learned before to create a new prompt, or a new prompt template in this case. And we can pass the loaded information to that template in order for me to get the result. And well, this is the summary for the story. And it was a small story, right? However, more often than not, we are trying to summarize something that's a little bit bigger. So what if instead of having to summarize a small story, I was summarizing a big story? And this is where problems start to appear, because this big story, and by doing the same thing that I did in the previous story, exceeds the maximum limit that the model has tokens for, and this is going to be a recurrent error. This is something that I've seen a lot. Sometimes we override the maximum amount of tokens that the model has, and how can we go from here into actually making it work? And in order for us to make it work, we have to do some things, and there are some solutions. And the one that I actually tried the most and had more success with was splitting the text. And also, we could have split it ourselves, but LangChain, once again, can do that for us. And there are different ways to split it. We can split it by token, we can split it by character, or in this case, I'm splitting it using a recursive character text splitter. What this does is this tries to keep the content as long as possible, and tries to keep the chunk size as close to, in my case, 500 as possible, by keeping all the paragraphs. And if it can't do all the paragraphs. It tries to keep all the sentences, and it's going to shorten by paragraph to sentences to words, and if that doesn't work, to characters. And in here we also have the overlap, and the reason to use overlap here is so that we don't lose context on what's going on, because if we split the text, we get multiple documents, and if we overlap the content, we can have more information that's from one document to the next. The end of one will be in the beginning of the other one, and sometimes this helps by allowing us to gain more context on what's going on in the story, for example. Now that we split it, we have an array of documents, and we learned about chains. So now we can summarize it using a load summarized chain. And like I mentioned, LangChain has these out-of-the-box modules that will help you with the things that you're trying to do. In this case, the load summarized chain will get an array of texts or an array of chunks of the text that we split, and it will summarize each individually, and then it will summarize the result of those summarizations. And if we run it with this, like this, it's going to work, because instead of us passing the whole story at once, we are passing it in chunks, and we are getting a summary of a specific chunk, and then we are passing the summaries, and it will work because we are taking tokens out of the equation here. This is not the solution for all the things, but more often than not, it will work very well with large amounts of text. And in this case, well, we learned about the MapReduce chain. We learned about how to load documents from external sources, how to transform them and split them into different chunks, And now we are in the last use case, which is agents. And agents are a new thing that LangChain, a newish thing that LangChain is bringing up. And what is an agent? Well, an agent is a system that will perceive its own environment, and it will make decisions and will then take action to reach a specific goal. And we, as the developer, we are the ones who specify that goal. All of the reasoning behind this is done by the large language model, because the large language model is going to decide what to do, and if we pass it tools, like I have here, it will try to use them in order to achieve the goal. Well, tools are not, tools are optional, but in this case, I have two tools here to showcase this functionality. And the tools that I've chosen was the SERP API, which allow the agent to search the internet. And I have OpenWeatherMap API to allow the agent to get information about the weather. So if we load the tools by their names, and we initialize a new agent, and when we are debugging, we have to set this verbose flag to true. And this is because LangChain made the decision to only output the last step of the agent to the user. So we don't see what the agent is doing. We don't see how it behaves. We don't see the decisions that he's making. So by setting the verbose flag to true, we can then see how the agent is thinking and how it reached those conclusions. Now, with an agent initialized, I can ask it a question. Also, this question is a string, but we covered this before, but it can also be a prompt template with a variable that the user is just going to specify. But if we run it and we actually ask the agent to explain to me what LangChain is, it is going to enter this agent execution chain. And because ChatGPT or GPT 3.5 was only trained with data from before 2021, and because LangChain was built after 2021, the model doesn't know anything about LangChain. So there is no way for the model to actually explain to us what LangChain is because it doesn't know. I mean, it can hallucinate and try to come up with an explanation, but it's going to be incorrect. And because the model knows that because the model doesn't know, and because I've specified that I wanted that he has the ability to search, his first action is going to be to use that search. And the second action, or the input to that action, is going to be a LangChain explanation. And that input is derived from our goal. And as you can see in the observation, it's a little bit crossed there, but the observation that the model gets is that LangChain is an open source framework that allows AI developers. So now that he knows that, he has a basic understanding of what LangChain is, so he can now give us an answer. And with this information in mind, the agent can give us a final answer that's not his final. So the final answer that you see there is going to be what we would have get if we didn't set the verbose flag to true. All the other things, the observations, the thoughts, the action and the action inputs, we were not going to see it. And this can also work with all the things that we talked before. We can have the agent grab the output, pass it to a chain, to other prompt templates, and as you can see, this is where modularity comes in mind when using LangChain. Let's go with another example. So, what's the weather like in Leiria? Well, the model doesn't know, right? It wasn't trained on that type of data. However, because I've specified an open weather map, he will get information about, he knows that he needs to use that API to get information about the weather. And it could derive from our goal, that is, that we want the weather for a specific town, in this case, Leiria. And from the API, we got a lot of information. And most of that information we don't care about, right? So we have humidity, we have wind speeds, we have a lot of information. But the model knows that because we just want to know what the weather is like, it knows to answer with just the temperature and how the sky is. So it's a clear sky with a temperature of 28 and 42 degrees Celsius. So the agents have these capabilities to think from themselves, to answer the goals that we give him. However, agents are not bulletproof. Agents have a lot of problems. They sometimes give you a wrong answer to your problem. They sometimes don't know that they can be using a specific tool. They sometimes provide results that are not relevant, and there are other times where they don't even reach their goals. But agents are more and more capable of abstracting the logic that us developers were trying to do, and instead of us having to do that logic, we can have an agent do that for us. And yeah, so in conclusion, there are more modules that I haven't spoken about here, and there are, if you want to look at the source, the LangChain documentation, they do provide more information about other modules, but I hope that you saw how powerful, flexible, and easy to use LangChain is, and now you can use these modules that they provide to build something like a Lego. Like you can build cool applications, powerful applications that use these modules that we've spoken here. Well, there are some others. And I hope that you did like this presentation. It was actually my first time presenting, and if you have any questions, I would be more than happy. I'd be more than happy to try and answer them.
So, any questions for Guido or Martin? You have a question, or you want to jump in already because you're the speaker? No, go ahead.
Really, for your first presentation, that was very good. So, awesome. Thank you very much.
Thank you.
And maybe a little bit tricky, and if you don't know the answer, or if you just can guessing. I mean, LangChain SDK is a really cool SDK to work with AI, definitely. But I could do all that stuff with the OpenAI SDK. So why I should perhaps prefer the LangChain SDK?
Well, that's actually a good question. We initially start, and by OpenAI SDK you are.
They have an API as well.
Yeah.
And some sort of wrapper, Python probably.
That's exactly what I said. So LangChain also provides these other integrations, like loading data from an external source.
Yeah.
Like you can load it from a text file, from a Notion.
I'm not sure. Maybe you can do this with OpenAI as well. I'm not sure. Maybe they have like. I guess they are learning from each other.
I actually haven't looked at that SDK in particular, but I think that these types of having to work with external data, having to do all of these text document transformations, like splitting the text, there is no need for you to use all of the things that LangChain has. You can use LangChain just for a very specific set of things. For instance, you can just have the external data fetching from LangChain and use the OpenAI for it. But because I'm using it already, I'm using LangChain for this, why not just use it for everything? So I have one framework for the whole code base,
yeah,
right?
I think this one framework is a nice direction because it's agnostic as well. You're not just,
exactly.
It's not just OpenAI, you can use other large LLMs as well. So, but yeah, good point.
Yeah, that was something that I didn't cover, but yeah, I used OpenAI, but they support many other large language models, Llama, Claude, even own large language models that you might host yourself. Any more questions?
Yes, just a curiosity. Thanks for the presentation. Do you use agents in production, and if so, can you give me an example?
Well, in production, not so much. Like I said, agents are a bit tricky to have them work as you intend, because they do have some ways to counteract that. They do have a way for you to retry the agent chain if the agent wasn't able to come up with a result, or if the agent broke somewhere down his chain of thought. But in production, I don't think they are production ready at this point.
Yeah, okay.
I mean, you probably can make it work, but it's going to take a lot of yeah.
Thanks.
Hey, so you showed the verbose output from the agent, right?
Yeah.
So is there like a specific sort of common use, a common way to access the in-between talks? Like
Oh yeah. Actually, I didn't show it, but you can make the agent output like in between steps, like you mentioned. So the output from a specific tool, or how the observation. You can make the agent give more information than the final result. There are some flags that you can append to the. If you want, I can try and explain to you in more detail, because there are some flags that you pass into the agent when you are creating it, and it will then give more results back.
And your example of the weather. Imagine you have this idea like I want to provide this for servers, so I also want to always include the wind. So how would you steer?
Okay, so the example that I showed, I just passed a goal to the agent. However, there are two more things that you can pass to the agent that I haven't showed here. You have a prefix and you have a suffix. And the prefix, it's something that you add to the prompt that LangChain is using behind the scenes for that agent. So in essence, it will append that information that you pass in the prefix in the beginning of the prompt. And the suffix is, well, the exact opposite. It appends it to the end of the prompt that LangChain has for the agents.
Hi.
Hello.
I have a couple of questions. First, presentation. One thing I want to know is how stable is the language model? In a sense, like, how can you be sure it's going to reply with a valid JSON or something like that?
Yeah. Okay. To answer that, we can look at it from two sides. We can either trust the model to output a JSON file or to output JSON code, because they are not going to output a JSON file. They are going to output code. Then LangChain is going to interpret that code and parse it to a JSON file that we can then use. And one of the things that I saw is that if we keep the temperature of the model really low, like near 0, it tends to do a good job. And if that doesn't work, LangChain also provides you with it's a retry that you can do, because if it was unable to parse the response, it will retry it again until it has a response that matches your schemas. And by using those two approaches, I've been really successful on actually getting the output exactly as I want. I mean, the structure. What you will get, sometimes it's a little bit...
Is the same thing for the metadata for the conversation? In a sense, use this format, reply as JSON, like the information that's around the question you need to do. Like, how can you be sure? Can you be sure that the model will comply, will obey those rules? Or like, is that probabilistic?
I mean, unfortunately, the model is not probabilistic. I mean, if you send the same prompt, exactly the same prompt with the exact same parameters that the model is trained with, you will not get the same result 100% of the time. So it's not something like a function that we are all used to. If we have a function that adds 2 numbers and we pass 2 numbers, the output is going to be the same. In a model, it's not going to be like that. And this is a mentality shift that we had to, and that we in my team had to come up with. Is we are not going to be sure 100% of the time that the model will comply with what we want. So, and in order to combat that, we do these other things around it. So if it's not like we want, we can try it again, or we can try tweaking a little bit of the numbers, because you can use a specific model with a specific parameters just to do the output being in the specific format, and all the other thing in your application can be using the same model with some different parameters. I don't know if that answered your question. A little bit?
Those guardrails are super useful as well. If you provide a lot of context, hey, you can only answer in JSON, you can only do this, and then you can make it pretty tight. And then it's black box testing anyway. So you are testing, try, it's a good answer next time, so that you get more and more sure.
You will get more, and I don't say that you will be 100% confident all the time. I don't know if that had also happened with you.
No.
But I wasn't able to get the 100% confident on that, but pretty close.
Yeah. Okay. And last one, sorry. Can I make a model to talk to another model? In a sense, for example, please make a resume of this, make this test smaller, right?
Yeah.
And then the model replies, oh, too many tokens. Then I get the same test as to another model. Please make it break down this test. Then the output, then get the output.
Yeah.
Return.
You can even have 2 models talk with each other,
Nice.
and that's really funny.
Okay.
There's an open source repo called GPT Engineer, there's an open source repo called GPT Engineer, which has like 60-70K now stars, and they make the use of this specific thing where you can make different models talk to each other. It's actually the same model, but each one is given a different description, so it role plays as something slightly different. And even the Stanford basically made an example of sims that were talking to each other, and even that repo is open source now. So if you wanted to just clone and try, we could do that with just putting an OpenAI token.
Thank you.
Any more questions? Oh, go ahead.
Yes. So I have a question here. First, thank you for your presentation. I think it was very good for our first time. And
I wish I knew this when I started.
it will be even better, I bet. So how does memory allocation work? Yeah, how do you like divide how are the tokens divided between the input tokens and output?
Yeah,
and
okay.
so generation and then memory.
So the example I had here, the model that I used had 496 tokens as a limit. That token amount is for input and output. So if I send 4095 characters to the model, it can only respond, tokens, it can only respond with one token. So that's a hard limit on the implementation of the model. That's basically how it goes.
Yeah,
You have a specific amount of tokens, I mean, it's not a specific, but you have this much tokens and it's shared between your input and also the output.
And then the memory, then it will be, if it is as intuitive as it seems, it will be like a third fraction of all those 4,000 tokens.
The memory?
Yeah, the memory. Because you have a chat and
Oh, you are talking about the chat?
yes.
Yeah, okay, so that's what actually happens is that information is appended to your message.
But so you're not, are you not spending tokens on having
You are spending tokens because what LangChain does behind the scenes, it appends the message history into your message and it sends everything.
Oh, okay.
So there are some strategies to work around that, but well, that's...
So it will be counted, it will be
Yeah.
Discounted from your
Yeah.
input.
Yeah.
Okay, thanks.
More questions, anyone? No,
Actually,
you have another. Go ahead.
A few more. When you can load a lot of different types of documents
Yeah.
to LangChain, and I'm wondering, okay, if you're not loading a text file, but for example a CSV, like what is the structure of the object that you create?
Well, basically, it's going to be the same. In the end, it's going to be text because you can only send text to the model. So even if you load a CSV, it's going to look like text for the model. And specifically, CSVs are a little bit trickier in some way to work with, but there are other approaches that you can take if you want to work with CSVs. They have agents that can look at the CSV. So you send, for instance, the column header, the header of your table, for instance, and then it can infer based on that and do calculations with pandas or with data frames to then work and don't blow the token amount.
So it will be something like probably like you have a row and then it's like you have the label and then the value for that register for that label, like kind of a dictionary. Will it be something like that? Because then everything is text.
Well, for a CSV, is it going to be exactly with commas, right? For Excel, it's going to be a little bit more tricky. I haven't loaded an Excel and look at the output because usually I pass that information to the agent for it to work with the data that I've loaded. But from what I've seen, it should be text.
Only text separated by commas.
Yeah.
Okay.